Good evening. I'm Ben Bogey. I'm in Connecticut. This evening, I am drinking a little Lawson Sip of Sunshine, a homage to Vermont, but brewed in Connecticut. So a little cross-pollination happening there. Tonight's topic is offsite panelization, in particular, mostly high-performance offsite panelization. BS and Beer is an independent grassroots movement to share building science knowledge through local meetup groups and this, our Zoom show. The Brew Crew and our guests volunteer our time each week to bring you what we hope is a fun and informative discussion. We'd like to thank Green Building Advisor and Fine Home Building for being our sponsors and helping make this happen. And most of all, we want to thank all of you who tune in and engage in this conversation with us. So with that, I'm going to hand it over to Emily for some announcements.
Hey guys, Emily Mottram here in Maine tonight. Still drinking water, kind of on the water train this week. If you're new to the show, the chat box icon is probably flashing on the bottom of your screen. We want to encourage everybody to tell us who you are and what you're drinking in the chat box, because everybody in the audience doesn't know you're here unless you post your name in the chat box. So say hi in the chat box so your friends know that you're there. It's also the place where you're going to put questions during the show. Please pick all panelists and all attendees when you're posting. And I know it's really annoying, but check every time because it auto defaults back depending on what type of device you're on. So to make sure that everybody in the audience also gets your questions, all panelists and all attendees. Fine Home Building sends out a reminder every week about the show, but if you want to know what the show is going to be and keep up with what's going on, pop over to the bsandbeershow.com and join our mailing list. You'll get a weekly email about what the show is and who our guests are going to be. Video recording will be up on Green Building Advisor tomorrow, and all the past episodes are up on YouTube as well. So if you missed a show and you want to go and check out our previous recordings, they'll all be up tomorrow. Also, the audio only version for those of you who like to take in your content as a podcast is available on Spotify and Apple Podcasts for those who want to listen to the show. Although there's usually some great graphics, so it's not as good if you don't watch the show. I'm going to add a bunch of links to the chat box for crossover events and other articles that are coming up or around this week. So if you want to have your announcements listed in the chat box, make sure you send them to us before the show. So Kylie, off to you to introduce our guests.
Yeah, with pleasure. I'm Kylie Jacques, and I'm the senior editor at Green Building Advisor. I'm drinking peach tea, not all that exciting, but it's doing the trick. Ace, I'm going to start with you because I have a connection to you, know you well, or no, to some degree. Ace is a co-founder of New Frameworks in Brattleboro, Vermont. The worker-owned company offers design and planning services, as well as new construction and renovations. Ace is passionate about building positive company culture, equity, and relationships between people. That's the abbreviated version. Is there anything you would like to share and tell us what you're drinking?
Oh, yeah. Well, the only thing I would say is that we are based in Burlington, not Brattleboro.
Oh, you know what? I'm so sorry about that. I do that every time, don't I? I think I've been talking about you based in Brattleboro for about a year now. So that's my bad.
Aren't you an editor, Kylie?
I know, it's terrible. Thanks for pointing that out, Ben. Okay.
Well, luckily, they're both great places. So it's not a problem to be mistaken for Brattleboro. I got a lot of people down in Brattleboro. Yeah, I guess the only other thing, I use he, him, and his pronouns, identify as transgender, and I wanted to share just that we had this really exciting article come out just this week through the Energy News. I can share the screen if you guys want, or we can do that later, but basically it's an Energy News Network article talking about our new model for improving farm worker housing by using panelization as a solution. So really psyched about that. And one of our new worker owner members, who's a former farm worker, was interviewed for it, Jose Ignacio. And yeah, it just is a great piece. So I'm really psyched. That's my big excitement this week.
That sounds very cool. I'll put a link to it when I write up the blog.
I put a link to it in the chat box as well. Somebody put it up in the show notes. So I put it in the chat box for everybody.
That's perfect timing, isn't it? Apropos. Okay, Alan Gibson is the owner of GoLogic, which he founded with architect Matt O'Melia in 2008. He's a certified Passive House builder and designer and secretary of the board of directors of the Passive House Institute US and the Passive House Alliance US. Alan, what else can you say and what are you drinking?
I am drinking a local beer from Searsmont, Maine, called Threshers. It's a lovely IPA. And yeah, thanks for the introduction. Fun to be here.
We're happy you are. Steve Hessler is a co-founder of Holzrum System. He's a heavy timber structural designer, a project manager, and a certified Passive House consultant with over 20 years of experience in designing, building, and managing off-site fabrication projects, as well as on-site high-performance construction projects. Welcome, Steve. What are you drinking? And is there anything we should know that I didn't include? Oh.
I think what you need to know is that I went to the refrigerator and realized I didn't have any beer, so I'm drinking ginger beer, which is super lame, but it's actually pretty tasty. And I'm super excited to be here, and we've been watching you guys, and yeah, this is great. What a great panel. We're really pleased to be here.
Wonderful. And Ilka Cassidy is also a co-founder of Holzrum. Am I saying that correctly? Holzrum System? Is that right?
Yes.
Yes, okay. She grew up in Germany and connected to the US while studying at the University of Washington in Seattle, and eventually she moved to Philadelphia, where she co-founded C2 Architecture. She is a certified Passive House consultant and an active member of Green Building United in Philadelphia. Welcome, Ilka. We're happy you're here. What are you drinking?
So I actually have a local beer from Germantown. I live in Germantown, Philadelphia, and I'm not the only German here, actually. And this is from Attic Brewery, and it's a Worcester Woods Vienna Lager.
Sounds delicious.
And I'm very happy to be here too. Thanks.
Ben, are you going to kind of lead? I understand that somebody has a presentation that they want to share.
Yeah, let's just check. I know Steve and Ilka have a presentation. Ace, do you have something? Yeah. Alan, you as well, sir?
I do, yeah.
Okay. Who's teed up and ready to go?
Okay, which do you see? Are you seeing the slide?
Right now we're seeing your back end.
Okay, switch displays. Here we go. Okay, good.
Beautiful.
Yes.
Yeah.
All right, thank you. GoLogic, we're a small design build firm, general contractors based in Belfast and Portland, Maine. We've been doing Passive House for a while. We built this was our first house back in 2010, first certified passive home in Maine, and only one of 12 at that time. And we founded the company to do all Passive House all the time and try to design buildings that would be, in a cost range that would be affordable to a lot of people. And we've been doing that pretty steadily and lately trying to look at our materials and make sure we have as much carbon in the building as possible and reducing foam and those sorts of things. We have built a variety of projects like these, some mostly single family homes, some larger custom homes, a little school. But our bread and butter is the Go Home, which is a line of pre-designed homes that range in size from 2,300 down to 600. Here's a sampling of a few of them. And the idea behind this is that we can reduce the architecture fee from this and streamline the process somewhat. They're not luxury homes, but they're also would be considered, fairly high-end homes for the rural Northeast for sure. And the way it works is that, we have a plan already made, but everyone kind of wants it customized to a pretty large degree, and we let them do that. So when we go to panelize them, they're essentially custom panels because they're all unique, and we don't have we have to use different shop drawings for every project. So we have ideas about how to work that out and streamline the process so we can actually take advantage of mechanization. And the reason behind this is this sort of thing, which I've been learning about through people from DOE and RMI. And you look at this graph and you can see how everything well, all of those major industries have been increasing in productivity over the last 40 years, except for construction, which is lagging horribly behind. And so there are a lot of smart people out there who are trying to crack this nut and figure out why the construction industry sucks so bad. And I like that idea, but I also think that part of the reason why this graph is going down, especially in the last 20 years, is because our buildings are better, because energy codes have improved. We're putting more stuff into our building. They're becoming better quality. At the same, during the same time frame, 2000 to now, the energy use in buildings has reduced dramatically. So that's part of the story. But I am really interested in the idea of how to make the building process more efficient. So to that end, we've been for the last 4 years figuring out panelization. And here's my crew in our little shop looking at a seminar from a colleague on Swedish panelization. And in Sweden, over 80% of all homes are delivered panelized. And they have the whole industry set up to work this way. And they produce essentially the same house we do with the same energy performance with half the labor time. And half is a big reduction. So there's a whole lot, there's a whole seminar about how, we could discuss how that's done. But we're trying to go on that model. And we have a very low-tech shop at this point. I have plans in the works, and I'm going to be building a much larger facility that will have some specialized tools coming in about a year. But we have framing tables. We have a few specialized tools, a little gantry, a couple of forklifts, and we are seeing the advantages to panelization at this level, which are number one, quality. They're being built indoors, not in the rain, not in the weather. You can take better care of the details, not being on some rickety staging up 3 stories trying to install and air seal a window. You're doing it flat on a table. And we are utilizing digital technology a lot more than a standard builder would by taking our architecture CAD and putting it into a 3D modeling program, which comes up on the shop floor so everyone can see every single stick in the assembly, and then it generates 2D drawings with cut lists. And the thing about this that's different is that you have to think about every single thing before you cut the first piece of wood. Otherwise, it's not going to work out. We are putting as much value add in our panels as possible. We always install windows. We put as much insulation in the panel as we can. And you will see from other folks tonight, Holstrom, a much higher level of mechanization and automation in their facility. And that's certainly another way to go about this, which is really exciting. Here's a typical build. This is from one of our first ones. This was out of state. We deliver panels. We stack them together. And then we typically put a truss roof on site and sheathe that. And then the local builder in this case did the finishes. Now this house, I've seen videos of Swedish crews who could put this house together on site in 1 day. And it took our crew about 8 days. So we've got a long way to go before we can get to that level of efficiency. Just some other shots. Here's a project we did last summer on a remote island in Maine. Here's a shot of our typical panel from the inside, which is on the left. We've got a 2x8 stud wall. We've got gasketing there, which is going to join to the next panel for air sealing. We've got a sheathing layer. We have 5.5 inches of wood, rigid wood fiber insulation, and then a vent space, and then another layer of sheathing as a nail base for cedar shingles siding in this case. So putting together the house, obviously you really want to make sure that these panels are going to fit, because modifying a panel on site is a real nightmare. And this house was put together in, I think it was a bit more complex than our normal designs, but we put this together in a couple of weeks. There's the, the building with a finish on it. And so that's kind of, in a nutshell, what we're doing to try to move construction to the next level of efficiency. But I also want to just leave you with a few thoughts. This is a little thought experiment I did, looking at the scale of the problem. So in Maine, we're a small state, 1.3 million people. We have about 500,000 households. And the Passive House Maine group thought it would be great to try to renovate with panels, panelized renovation, 50 houses in a year. Well, actually 50 houses, however long it takes. But imagine if we could do 50 houses in a year to get to a passive house level of renovation to some of our terribly old housing stock. Well, that would be great, wouldn't it? But it would take 10,000 years to renovate all of those homes in the state of Maine. If we wanted to reduce our target, let's say we just do 10% of those. Let's try to aim for 50,000 houses. Still, if we're doing 50 a year, it's going to take 1,000 years. And we know with the climate crisis, we've got like 10 years to act. Okay, so how do we do this? How do we achieve this? Well, my concept is we have to have a distributed network of relatively small scale panelized shops that can make, you know, a reasonable number of houses a year, say 25. And if you do that over 20 years, if you have 100 companies doing that over 20 years, well, there you've got you to your target. And from everything I read, that is even too long a time frame. Like, we have to act extremely quickly, get carbon out of our buildings, or sequester carbon into our buildings, get fossil fuels out of our buildings, to try to get a handle on the climate crisis. And it also, in my mind, is, you know, what the Green New Deal is all about. It's getting companies to do innovative technology, however it's done, to try to solve the problem. So that's it for me. Thank you.
Thank you, Alan. That was great. Ace, do you mind going up next?
No, happy to. Yeah, let me just grab my share screen here.
Just so everybody knows, I think we're going to just kind of tick through the presentations. That's our normal routine, and then we'll open it up for conversation, questions back and forth after that.
Okay. Alan, that was awesome. I'm so inspired. I can't wait to discuss. All right. Well, here's a little from us. So we are a design build company. There are 22 of us. We're a worker-owned cooperative, as was mentioned, based in Burlington, Vermont. Although we also have a design office in Montpelier, central Vermont. And we have two products that we make, and one of them is the Griffin door, which is a high-performance plant-based, a high insulated door that we make. And then the second product is our Griffin panels. So that's what I'm here to talk with you about today. So in my bio, it mentioned that I like to talk about relationships and how we work not just on a building science level with physics and materials, but also with people. And I think like all of those levels are as important. And climate justice and racial justice and social justice need to be at the core of our work. And one of my wishes is that we're going to get as technical and geeky about that as we are getting about building science. So that's my dream, and that's going to be a part of our skilling up. So this is a part of our recent partnership that the article is about, working with Migrant Justice, which is a group here in Vermont that supports migrant farm workers in our state. And we put out a call to see if any folks would want to come and work with us and join our cooperative to be on our panel team. So that's one of our base partnerships, is with Migrant Justice and the migrant worker community. And the Nitty Gritty Grain Company, which some of you might know, they're really awesome products. They make delicious corn pancake mix and muffin mixes and stuff like that. Their farm where they grow their grain is called Aurora Farm, and it's based right here in Charlotte, Vermont. And they are a 7th generation family farm of settlers to Vermont, on occupied Abenaki land. They grow heirloom seeds and heirloom wheat with all of their grain crops. So we're just psyched about that because it's many layers of work on the supply chains that are happening at multiple points and many points of intervention that can be hit. And for us, we want the vision of where we're going is climate justice, just transition, a new structure for our region, our bioregion, that is a regenerative one. So how are we going to get there? And we have to hit leverage points on multiple points within our systems, both ecological, social, economic, political, physical, all of the spots. So this is our attempt to try to hit a bunch of those points with our work. So yeah, the production of the straw coming from a super local small farm, and then partnering with key social movements in our state and communities that really need support. So this is our production team. We just got some really great photos taken, and we're really just psyched with everybody. Notice that the presentation is in both English and Spanish, and that's because we're also, as an organization, working on language justice and really acknowledging that, in order to be equal with each other and in an equitable relationship, we need to be able to honor each other's languages at equal value. So we're also working on all of that, which has been a really great adventure and really wonderful as well. So anyway, this is just a short, fun video. I mean, who doesn't love a short, stop action video putting a panelized product together? So this is our fun thing that we came up with this year, which is called Tu Cabanita. So it's a small cabin, and basically the idea is to start somewhere with a pre-designed, prefabricated straw panel project that folks can really it's super easy to say yes. That was our really big goal with it, is like, how do we make it really easy for people to say yes to this? And it was meant to be a starting point of a studio, a cabin in the woods, ADU, type of thing. So it's not meant to be a full home, but our intention is that using this as a proof of concept is going to then, allow us to build into, modularize into larger things. Sorry, it's stuck on my video now. There we go. Okay. Whoa. So yeah, just a few more photos of our team. And so the team builds 2 different types of panelized things. One is currently the pre-design of the cabanita, and then we also do custom panels. So people will bring us their designs, and we will evaluate them to see how appropriate they are for panelization. And then our design team will do that intake and that work, and then we'll fabricate panels for them to their design. So they're kind of 2 different ways that the straw panels can happen. And yeah, similarly to you, Alan, our shop is, it's pretty roots. We don't have a lot of, big equipment, not a lot of fancy stuff. Almost everything was made, you can see kind of the welded metalwork in the background. We used Barrie, Vermont, which is a working class, machining town in our state. We work with metal workers there to build our tables, and yeah, a lot of stuff is fairly low tech and accessible. And that's by design. We were very inspired by Chris Magwood and Jen Fagan's work from the Endeavor Center, and just the idea of that decentralized, easy, pop-up, democratic, like, this is not hard, everyone, we can do it, was a big part of what inspired us. And that's not to say that we're opposed to anything from computerization to other things that make the work easier and make it flow. So it's not an opposition to that. It's just that wasn't a part of where we began with this. And then, here's myself and Devin, our project management and business development team. And our design team, Beto Silva, Julie Krause, and many of you know Jacob Rakusin from many settings. I think he's been on BS and Beer a few times. And then if you wanted to just get an idea, it's pretty simple. We have the air barrier, the interior framing, straw bales, and sheathing. We are actually also doing offering a panel that has exterior as well as interior plaster as an alternative to siding and sheathing. And that's been interesting. We've had fun engineering that structurally and working on diagonal bracing or other forms of structural support if we're not doing the sheathing. So this is a little cheat sheet that we've created for outside architects and folks who collaborate with us to kind of understand the way it works. This is just another example of the little cabanita, and there's some more of us having fun. This is a fun little sketch that our design team came up with. We're really working on how to connect the idea of the micro to the macro and really pull out that multiple levels of impact that one action or one project can have to build that just transition and that bioregional remade economy that we're looking for. So that's been a fun challenge for us to try to articulate and do. I think that gets me to the end. Yeah, really just more panels. I have to say, Alan, you mentioned many things that are great for us too, it's a lot safer, you're in a controlled environment, you're not up on the stage, all the things that you mentioned are also key for us. And I think the accessibility that comes from being able to have people with different body physicality and ability feel much more ergonomic and able to approach the work in the setting of a controlled environment is something that we also see as really positive, bringing in people of more genders, more different kinds of physical ability as also a really positive aspect to the panelization. Yeah, that's pretty much it.
That was awesome. Thank you, Ace.
All
right, Ilka, you're up.
Yeah, let me try and share here. Okay, so we're up. Yeah, thanks. This is awesome. So yeah, I guess we were already introduced, so I don't really have to talk too much about us. I just wanted to mention that yeah, I guess what's kind of interesting about us is that we're just kind of looking at things from all different angles. So Steve is kind of coming from the construction side and timber frame design and CNC programmer, me coming from the architectural side, coming from Germany. So it's slightly different kind of education path there too. We're all passionate about Passive House. We're Passive House consultants. We do energy modeling, and then we also have David on the team. He's co-founder as well. He's actually Steve's brother, and he is a biologist, but he's also a software developer. And we also always say he's the voice of reason. He kind of, whenever we come up with all these kind of crazy ideas, he's always saying what you have to really be clear and tell me about it in form of data. So it kind of reels us back a little bit. Which is really good, and he's always trying to look find efficiencies in what we're doing, because Steve and I were always trying to come up with all these different things. Let me go to the next slide. Yeah, Steve, you were going to say a little bit more of what we do.
Yeah, so we're not a factory actually, and even though we work with a few factories. And yes, some of those factories have some very large and shiny tools. We're actually a design translation company. So we basically connect design intent and the goals of a project for single family mostly to we connect them to Passive House goals and program goals and builder goals and factory goals, and sometimes localized fabrication goals. And we do this through creating this, what we call the single integrated manufacturing model. So we figured out that we need a model to produce something, to create shop drawings. And so we started to enhance the content in the model so that we could start to use it as more of a coordination tool with the rest of the project, right? So we're sort of trying to tie things in, not just the things that'll be fabricated, but also, you know, MEP and foundation and structural steel. And we bring all of that in and then coordinate it all to make sure everything will align, and then kind of feed it back out.
Yeah, and this is actually a project that Kyle Macht actually presented on Tuesday on the Passive House Accelerator Tech Tuesday. So I'm sure it's all recorded. So if you want to know more about this pretty amazing project, you can check him out too. So we always kind of try and find just ways to, you know, play with the software and do whatever, kind of explore what it can do. And we come up with these animations. And I was actually working yesterday on editing this, and my youngest daughter came in, and she looked at it and she was like, "Wow, this is cool. It kind of looks like it grows. It's almost like a flower or like a tree." And I was like, well, that's pretty cool that she's thinking about that. And it kind of, I don't know, struck me somehow. And I called up Steve and I was like, this is what she said. And we kind of revisited what we were going to present today, and kind of rethought a little bit this concept of this, you know, this metaphor of a tree, and pulled up this graphic that we actually very similar to this presented like years ago at or was presented. We just supplied the slide at a Passive House conference of this idea that we have of having the single integrated model that talks to everyone, that becomes a communication piece. And back then, I think it was like 3 years ago, we actually didn't really know how it was going to work. We had some ideas, but we didn't really know what exactly that would look like. So yeah, we've been working really hard on making this happen. And yeah, I mean, we're not, you know, of course, not always exactly there, but we got a lot closer over the last years.
So the idea, basically, the main takeaway is that if you don't read anything on there, the thing to know is that everything in there feeds the model inside, and the model feeds back out. So there really should be arrows going in both directions from absolutely every stakeholder, player, goal, location, climate. And what we try to do is bring all of that in, and then as the model grows, just like that kind of tree metaphor, it sort of gets roots into all of those different perspectives and you know, into the players, and it's thinking about, you know, the builder and like, what kind of trucks does he have, and what kind of, if he's going to fabricate these panels himself, what kind of tables does he have? Does he have, you know, a gantry here? So basically all those things kind of feed in and then feed back out until it's ready to kind of go into a production.
Yeah, and what that looks like in real life is we kind of recorded some of our charrettes that we've had with the structural engineer on this particular project with Kyle Macht, and the structural engineer, and it's just kind of amazing how this model becomes a communication piece or a harbor of information. We have a design log that everyone has access to, and we can kind of pick out, okay, this is an issue that we need to talk about, and we go into the model and kind of turn around the model in 3D and can really just kind of in real time either make adjustments or you know, kind of mark things to go back to later. So here's a sketch by Kyle that we looked at on Zoom, and then we actually went into the model and just kind of zoomed into that location and talked about it. And this is a charrette that we had with the MEP engineer with positive energy, and they actually supplied the MEP model as well. So we didn't generate that; we just kind of transferred it into our model. And we kind of look at that clash detection and see where are they issues, and take screenshots and put it all into a log. And so what this does is that we become very early on part of the team, part of the design team, rather than looking at this in kind of a linear process, just as the graphic showed. We kind of look at it as a very just kind of back and forth of data flow. And we were really always happy to be in that process, in the design, and just kind of facilitate information.
And then some of the results then of all those, like all that kind of team charrette and design collaboration, come out then in the form of a geometry review set. And like in this example, this is just one of the floor framing, the truss floor framing layouts, where we brought in the original layout from the floor trusses from the manufacturer, and then we sort of aligned them because they weren't totally aligning with some of the architectural program and the goals there. And so we align it with structure, and then with MEP. So the green is shows ductwork layout. So we then can communicate back out to the truss company and the MEP, and everyone involved. This is where we need call outs and clearances for ductwork and anything else.
So and then another output is of course the panel drawings. So what we realized is this is basically kind of coming from this model, and we've worked with Blueprint Robotics before, where the output was mostly a machine files. So all the robots or the machines get fed these files, but this is also a way to just kind of make it into a kit of basically just kind of drawings that can be used by anyone really to build these. And then there's instructions on how to put this all together, and panel orientation drawings. And then we will also be able to use the model to generate information for FIAs in terms of air layers and just kind of detailing, but also to use this as a instruction for the installer in terms of sequencing of leaders to connect air layers, and what to watch out for. And then what's really exciting is that beyond our scope, the builder can actually use this model on site. So this is Chris from Haynes and Fine Building, and he's actually very comfortable using this model now. So we kind of set it up in a way that it becomes very user-friendly. He actually got a free license, a viewer license to use this model. And now he can actually communicate on site with subcontractors. And since we kind of modeled everything in there, not just the panel scope, he can talk to the steel fabricator, he can talk to the plumber, the concrete panel maker, and everything else.
So we also realized a little while back when we started creating these very kind of detailed high fidelity models with all the parts, we started adding in all these other scopes, not just the fabrication piece. But what's really cool about these models is each of these parts it's almost like it's like a visual database, right? So you can assign like almost infinite data, of course, only when it's useful, but to every object, and then you can harvest it out. And so we started thinking, more and more like, well, this thing's not just great for fabrication drawings and coordination, but it's also really good for like things like costing, so we can use it early in a project. And so we've now been engaged to help people do really early feasibility checks. Like what's the next? So this is a really cool, we're excited about this. And this, I think, kind of aligns with Alan and Ace. We absolutely agree. I was excited to hear you guys say this, but there's no way we're going to put a dent in this carbon crisis doing these massive, like we've been lucky, right, to do these amazing projects, and they have absolutely funded our development and like what we think can happen here. But we're crystal clear, we have always been, that it needs to get out to the masses. And so we've really been excited to finally, now we're engaging local labor force. And so this is a super exciting project for us. There's 3 buildings, a 6-unit and a 2-unit multifamily buildings in Baltimore that will be built by a local Baltimore contract. It'll be funded by the South Baltimore Community Land Trust. And I just have to read this because I have to make sure you understand. This is such a great little program. So the SBCLT is a 501c3 nonprofit community land trust with multifaceted programs. We sell homes to homeowners through the CLT, develop youth and community leadership opportunities, advocate with residents for healthy and regenerative zero-waste economic development, facilitate planning processes, partner to provide workforce development and financial coaching, and help youth become leaders in their communities. So in the city of Baltimore, these houses will be built and owned by local residents. And they're actually also engaging, the Carver Institute is a vocational school that will be bringing student labor force into the build. So they have a great warehouse space, and they're gonna build the buildings that we helped kind of design with them, just completely low-tech, panelized on tables, and we can't wait to get into that. Next slide. So just at a very early, like we're really just getting into it, but even at a very early level, we're able to like throw in, these are their actual like ROs, but I haven't even really modeled in all the roof geometry yet. But even at this very, very early stage, we can kind of auto-populate a fairly realistic labor list, and then we can automize it for like super efficiency and find ways to cut costs on everything. They have access to this model. They can access takeoffs and volume and surfaces like instantly with any individual material, or also like that building on the right has like 6 different units in it. They can isolate cost and look to see what the feasibility is of losing an upper loft. In the meantime, they're also doing the passive house energy modeling. And so we're kind of doing the same thing now, where we're feeding back with the community on cost for the project before they've really decided what path to go.
Yeah, and we are also engaging with the potential builder who will be building these panels locally, and they've never done it. So we'll be talking to them about, okay, how big are the panels? Like what is your preference there? Because we can splice and dice the panels however they prefer, right? So we can talk to them about that and the air sealing, and since we again kind of have this model that's very visual, it's really easy to communicate all of these things. And this is also something that we're excited about, is just kind of looking at opportunities with other materials. I mean, we're very interested in CLT. We have a partnership with Stolz Timber in Montana, and we've kind of looked at buildings in CLT, but sometimes it doesn't really make sense to it might not be cost effective to build the whole building like that. So we are just kind of looking at hybrid solutions and can kind of swap out scopes here and there, and everything is going to be still fully coordinated.
So everything we do is vapor open and foam free. We've never, once we started Holstrom, we made a clear decision. So in this case, this is obviously sort of a dream assembly. 2 layers of wood fiber insulation on the outside. It's sort of a glue lam, thermally broken cantilevered structure above. And if you strip layers, you can just kind of cycle through, Ilka. We get it down to the CLT walls. And so just keep going through. Basically, we're just sort of deconstructing the build here and taking it back down to walls, and then right here, just hold right there. So then we thought, okay, what if we now come back up looking at, maybe a really cost-effective frame, high performance wall that could either be site built, or maybe it could be a panel that could be delivered on site. In this case, we kind of build back up our typical closed wall with a zip sheathing on the inside as a vapor retarder. hemp insulation, Styco insulation, battens. So like there's just sort of endless opportunities, and then that could still potentially work with, you know, a CLT, either domestic or imported CLT, especially if we work it in with another project. So we just kind of find that it's the method that we're working on that we think can be really applicable, as long as we always keep in mind that we are only interested in super low carbon, and what we'd really like to do is try to get more people in the game. And that's it. I think that's it.
Yeah, the only thing that I just wanted to quickly mention is the project that we showed first, that's actually being fabricated right now in Rochester by New Energy Works. So I just wanted to mention them real quick.
They are an exceptional company.
Mm-hmm. Okay, that's it.
Thank
Ilka,
you.
Steve, thank you. So we have a list of questions now. For everybody. Our favorite Mike Maines has been steadily behind the scenes here populating questions for us. I guess the first one on our list, and we'll just work through these in no particular order, is do you see that you can produce panels faster in the shop environment than you can in the field? So when we figure in the production time, delivery time, the time to set and install the panels, is that generally shorter than a traditional site built time frame? And obviously that can vary depending on what the structure is, but
I would say almost always yes, but the design time is much longer up front. That's our experience.
Yeah, that was actually one of my questions all the way at the bottom of the list, was to go back to that. How long, like, what's the design time from the time you guys get an initial sketch or whatever from the architect to production of that level of drawings?
Is this for us or for everyone in the panel?
Well, that was for you, but I think that Ace and Alan can probably respond to that as well from their design aspects.
Well, I'll just say for that was one of the most complicated projects we've done, and I would say that one, you know, it had been in design development before. So some of the projects come in really early, and that's great when they do. It's really good for a panel design company to kind of get involved early, but it doesn't typically happen that way. So that thing had probably 6 or 7 or 8 months of pretty heavy architectural design, and then we converted it a bit. Actually, the architect kind of knew the assemblies that he wanted to do. He knew about our assemblies and he wanted to go that way. I would say once we really locked in, if we were kind of full time on it, it probably would have been about 4 months of you know, fleshing out that model, but typically it can go much quicker on a less complicated building.
Yeah, so when you shift from site built to panelized, there are things that you have to add. You have to add the shop drawing process. You have to add a crane and some special rigging and trucking. And those are all on the add cost side of the ledger. But on the reduced cost side of the ledger is the actual per square foot cost of the building envelope. And at what I would say at this point, Geologic is kind of, you know, I can't say that we're producing our panelized homes any less expensively than built on site, because we haven't crossed over that cost barrier. And the only way we're going to do that is by having designs that are more replicable. Because if we can do 2 houses with only 1 set of shop drawings, well, then we eliminate all that shop drawing time. There are other people who have been doing this for a long time. Adam Cohen developed Build Smart panels, which are modular panels. They come in 5 sizes, you know, 1 foot, 2 foot, 3 foot, 5 foot, and 8 foot, and they have standard windows. And it's kind of like, yeah, it's really simple. You have some simple jigs, you build these panels, and then you can design them all in like a modular system, and anybody can build them and anybody can install them. So it's not very highly skilled, especially on the installation side. But it's very limiting on the architecture side. So I think there's this real tension between, you know, what your design is, whether it's even feasible to panelize it, because some designs just aren't. But what can you do to make a really replicable design that could be mass produced and reduce costs significantly? Is that going to be acceptable to the single family house market? It's really quite applicable to multifamily, where you have a lot of repetition. That's where everything, you know, the shell of all like 4-story multifamily buildings should just be panelized. And I think the industry wants that, but it's a chicken and egg thing. Anyway, long-winded answer. There are some things that you save money on and some things you spend more money on with panelizing.
Why do you guys think our industry has been so hesitant to adopt offsite? You know, I've been in this
Well,
at this for 25 years, and it's always been the next thing coming, but it's still.
Right, exactly. Yeah, the building industry is really conservative. And, you know, the home, like NAHB is just like a conservative. They don't want to change anything. It's just like the car industry not wanting to embrace electric vehicles. And it does take, you know, I'm looking at taking a big leap and investing a lot of money and taking a big bank loan to build a facility that will allow me to panelize in a more efficient way. But it's scary as hell. And I, you know, for a small time builder to like do the investment needed for that, it's a big leap. So, and I think whatever, there may be investors who are interested in doing it now, but that's a big hurdle, and it's a learning curve.
You know, there's a part, I think, in the, like, Alan's totally right that the building industry is quite conservative and like very risk adverse, right? But the funny thing is we constantly have these conversations with builders who haven't done some sort of panelization. And what we explain to them is that as soon as you introduce a level of manufacturing into a build, and then maybe, like, I loved what Alan said, is they try to value add to each panel. We totally agree with that, like, because what I think is that the more you build in that is offsite manufactured, then it forces you to do upfront design and evaluation, and it's straight up risk mitigation from my perspective. I mean, literally, Ilka and I were an architect build. We were 2 companies that worked together, and we just got into panels. We did Build Smart, was our first one, and we got into panelization not because it was cool, but because we were tired of getting burned by doing everything by hand, especially with Passive House. And the more and more we brought into of offsite manufacturing, even though it absolutely required like this upfront, you know, analyzation, it totally just, we started to find the risk bucket. You know, that's what we do with a model. We started to find it, identify it, address it, resolve it, and then go put the thing up. And it really, like, it's sort of just, it's a transparency, I think. And that's what I really like about it. So that's kind of the answer to it. As far as the cost thing goes, I would say, you know, we typically, you know, I don't think any of us here would be in business if we weren't competitive, right? Nobody's here to work for free. And that means that if you compare us, I bet I'm speaking for everybody, if you compare us to stick-built, similar, you know, like low carbon, super healthy, vapor open, you know, remember vapor open means that you've eliminated mold risk from your build. And builds are very tight these days, you know, whether you like it or not. They're tight homes. You throw zip and tape up and you have a Perm 5 non-breathing building, period. I don't care what code it is. And so for us, you know, that's why it's vapor open. It's really about mitigation, again, of risk and health. But if you take a building from any of the 3 of us here and you compare it to a similar quality and health build by hand, I guarantee you we're competitive. If you compare us to code build, no, we're not going to be competitive. And there's a reason for that, because now you're throwing the risk and health out the window, and you're just, you know, sometimes you're going to win if you get a good builder, and sometimes you're going to lose. But we're just trying to identify and just like eliminate the risk. So
It's a lot safer, more efficient, more productive for us to figure out why that beam doesn't line up with that point load in a computer than it is for us when we have a framing crew standing around on site. So,
yeah, or a thermal bridge that might condense.
Yeah.
I also think that there's reluctance because everyone is just so used to kind of working within their bubbles. You know, the architect works here, and then they just kind of produce this drawing set that then goes out to bid, and then someone gets picked to build it, and then the responsibility shifts there. You know, it's kind of this whole thing of liability and these like bubbles and kind of handing off things. And even within the builder kind of community, every general contractor has their preferred subcontractors, and everyone has preferences. And by doing panelized, it kind of all gets a little it's different, right? Because all of a sudden you kind of have to stop to talk to each other, because the architect has to engage really and has to make these early decisions, and the builder or in our case us and the manufacturer, we all kind of have to talk to each other and find a way to figure this out beforehand. And I think it has great opportunities, because I think it's important to cross over and not stay in these bubbles. But it's different.
For myself, I've started looking at it more so recently because the skilled trades gap. It's really kind of forcing us to. We're getting into a situation, especially in a market like we have right now, where we have a lot of demand for housing to be built, and we don't have the people to build it. And a lot of our better skilled carpenters and framing crews are in their 50s and even 60s now, and these guys deserve to retire. You know, they've put in their time. So who's going to replace them and be able to deliver that level of quality? So that's what's forcing us there. In kind of a more concrete realm, what are some special considerations that we have to make in the field to prepare ourselves for panels if we're doing a panelization? You know, foundation considerations, site considerations, that type of thing. Anything that you guys can share there, pearls of wisdom?
Yeah,
I have one to add. Don't do it in January on the top of a mountain down a 1,000-foot driveway. That was not great.
yeah.
Sounds like it stung.
That's a good point. If you're bringing a 70-foot tractor trailer in with panels on it, you got to make sure that the driveway can handle that. We've done a lot of projects where we've had to transfer panels to a smaller truck to get up the driveway. Just add time and aggravation. That's important. The foundation has to be the right size and shape and level. And if it's not, you've got to fix that before the panels go in. We've spent lots and lots of time fixing crappy foundations that other companies have done, not our own. But then you have to have more sort of lay down area, depending on how you do it. If you bring panels in and you offload them in an area, there are usually other materials that are on site as well. So, and then you have to make sure that your mobile crane can get to the point where they can reach the far corner of the building, or use some other construction tool like a telehandler that can get there.
So is it common practice that, you know, panels are coming in prior to them being set, being offloaded on site and then flown into position?
That's what we do. Yeah, we have, you know, 3 or 4 panels on a rack that gets taken off the truck and set on the ground. Then the truck can go away, and then you can set your panels. But in Sweden, they have these amazing trucks with covers over them, and the truck driver is part of the company, and they help, you know, rig the panels, and they stay there. The panels don't go off the truck until they go into the building. Way more efficient. And
you don't have to lift them twice. Yeah.
There's so we've, you know, with some of, again, we're not a panel company, so we just get to play with panel companies. But the panel companies that have manufactured our homes, there's a couple cool racks that we've used, or that they've used. And so the idea is that the truck comes up, rolls onto site, and if you make the rack like a steel rack, right, especially for like vertical shipping wall panels with windows in them, if you make the rack right, and you can stick a bunch of panels in a rack, and if you put 2 or 4 racks on a truck, then you can pick the rack, and you can basically offload the truck quite quickly, leave the racks on site, truck goes, when the next truck comes back, it picks up the racks, and it's sort of this cycle. I mean, I don't know how efficient it is for a smaller home, but like one of the homes we did last year was like 10,000 square feet. So it was a lot of panels. It was, I forget how many days of panels. And it was great because their trucks were coming from Baltimore, and they were doing 2 to 3 truck deliveries a day. And those guys are just coming and getting empties and then coming back. And so I could see something like that working for like larger, or also like multifamily buildings. But a lot of the projects we've done have been larger. The smallest panel project we did was only, I think it was still like 3,000 square feet. So we're hoping to do more smaller ones, and maybe we'll come ask Ace and Alan how to do it.
Ace, I'd love to hear, I mean, you and I've spoken. How do you sell this idea to your clients? That's what I'm kind of curious to know. I mean, there's no doubt it's costly, right? So I'm just kind of curious how you put the pitch to them. I mean, people come to you, I'm sure they already know what they're wanting, but generally speaking, maybe you can share how panelization is presented to clients in such a way that it makes it attractive and worth the investment.
Sure. I mean, I think really tangibly, the schedule aspect is appealing. So for us, it means that, we can build with straw, which is a tricky, site-based material to utilize during a lot of the heavy precipitation times that we have in the Northeast. So, for us, and the super cold times too, if we are utilizing plaster, that also limits the window of time that we have weather where it's acceptable to utilize that. So I feel, and then of course, all the other challenges that we all know of, tools freezing in the winter and batteries not charging and all the stuff that you run into when you're trying to build year round. It makes it way more accessible and possible for clients to get a straw bale home in a schedule that makes sense and can fit. One of the things that we've seen is that in addition to our panelized sort of division, simply offering panelized products to an outside design or to or as a pre-designed package like the Cabanita is also our internal design build team, which is operating our own custom design build projects, using panels as an insert into our own process of build. So we're sort of our own customers internally for that. And what's beneficial about that is that we can have our site team building at the same time as the panels are happening in the shop, or maybe even before we even break ground. Those have been completed and we're working with our design team. So it's a nice way to actually shorten the time schedule for folks and to make it a lot easier to put those panels up and build with straw bale in November, December. One of the schedules that we've been looking at is getting that site work done and foundation and all of that, utilities, et cetera, in the fall, and being able to have the panels being built simultaneously so that then they're immediately ready to go on that foundation, and we can fly a roof in. We've also I saw earlier someone in the chat had asked about panelizing roofs as well, which we have been doing. Partly also inspired by Chris and Jen at the Endeavor Center and their Zero House. So, once we get to the point where we're able to essentially create, a weatherized shell in what looks like magic time, from the perspective of the site, it's a big benefit. So that's one of them. And then of course, speaking about the vapor open assembly and how that, is a insurance on long-term quality of the build. For me, it's also about, if we really are taking seriously that what we're doing with these buildings is creating the 6th carbon sink and essentially storing carbon in our buildings and partnering with plants to do that, to draw down carbon and reverse climate change, then we have to actually build durable buildings that are going to lock that carbon in and not have it rot, or mold over time, right? Like that's a part of our mandate that we're taking on. So I think also for clients, the appealing nature of it is not just the convenience around schedule, but also the sort of guaranteed quality and vetted pre-design that we've done as our team, and using our years of straw bale experience to really kind of crystallize that into this product, that they don't actually have to make choices. I'm going to piggyback on an earlier conversation, but, kind of like, what is the difference between panelization and building on site, and why has it been hard for the trade to shift? And I think that there's a lot of reasons, but one of them is that we're so used to just responding all the time to clients in a custom setting. It's a really huge shift to turn to saying, nope, we have decided as builders, we've seen a lot. We know how to do this in an efficient way, and in a way that's going to store carbon, do all the other things that we know we have to do, keep our people safe when they're working, bring more workforce development in, all this stuff. And we've said, we can actually offer more of a product. Sure, there are, customization options within that. And it sounds like everyone here does different levels of allowing that customization. But I think that there's something about really streamlining and consolidating that knowledge that we've all really worked on in our fields to offer a product. And that is a very different model, in addition to everything that everyone else named about the expense of, investing in a warehouse space and, the trucking. It's a very different pipeline. It's a very different flow. It's very different for setting client expectations. And I personally think that as we're looking towards, again, that just transition, that climate justice future, like climate refugees, coming to our region, we have really major challenges that we have to meet as a design and building industry. And I think that, I just lost my train of thought. That's amazing. Anyway, we've got to have, easy solutions, I think, that are not custom, that do not rely on, very entitled clients that want everything, bespoke. I think we're really looking at how do we democratize and make more accessible this work. And to me, panelization is a key part of that.
Steve touched on it a little bit earlier, and I kind of call it like the Robin Hood philosophy. Like, for the most part, everybody here we're working for a very affluent class of clientele that's allowing us to practice this work. And I feel like it's kind of, at least maybe this is how I go to sleep at night, is that I'm using their capital and their willingness to allow me to practice new methods in order to create these supply chains and create these neural networks and create this workflow so that we can start getting it out into the masses, because it is kind of a contradiction, some of the work we're doing. And it's along the lines of what Ace was saying, for me, it's a risk reduction. It's a risk reduction for the client, because say, we're building in January, February, work slows to a crawl. We're making progress, but work slows dramatically. So if we can deliver, an enclosure to a project in a set amount of time, there's less chance of risk there. It's also less risk to our subs and crews having to be out in the weather and work in difficult conditions and potentially get hurt, or, all of these things. So it's just smarter.
What Ace said about the ability for like a panel company to kind of figure out what assemblies work and what products work, and then specify that, is a huge thing. I totally agree. And our client for that large building that we are working on now, Kyle Mock, the architect, he told us that one of the reasons that he really was looking at these high performance panel companies in the first place was because of that. It's like, the three of us are companies that are saying we're only using, like well-sourced lumber. We're only using, low embodied carbon materials. Like, it's not just about the building science, it's totally about the carbon and the ethics. And, that's cool to have that built in, and not, in a project, there are so many decision makers that can knock off, the low embodied carbon is the first thing to get knocked off of a project spec, right? Like, so the architect is like, I actually wanted to do this, and I know if we go with you, that I don't have to worry about it, because it's the only way you guys are doing it, right? I think that is really a big deal, actually. I like that. We actually saw Alan's assemblies before we were ever even close to a company, and he's been using, pretty much very similar materials that we ended up falling in love with. But we watched him use it for years and years. We would see him presenting it at FIAS, and I was like, that's what I want to, actually, I think I said, I want to go work for Alan because those are buildings you could be proud of. And, now we're proud, we're proud to just say, no, we're not even considering using that product. And we also love that we have the building science to tell them why it's a terrible idea to put a piece of plastic in an assembly, So thanks for letting me rant.
So what are some?
Thanks, Steve. Yeah, we've definitely evolved. We used to do a lot of SIPs buildings with foam, and then we switched over to mineral wool because we thought that was better. But turns out it's just as much embodied carbon as foam. Yeah. So then we turned to wood fiber, but that's hard because you have to source it from Europe. We're waiting on our spin-off company Go Lab to start making wood fiber in Maine and shipping it around the country, but that's still a ways off.
That's awesome. That's exciting.
Yeah, and then I'm inspired by new frameworks and putting agricultural products, which is way better in terms of carbon sequestration. And we've tried. I wish I could get my hands on some hemp insulation. I mean, I have, but I wish I knew how to cut it and work with it because this stuff is incredibly tough. So anyway, that's
another great point, Alan. I know. I mean, what are we seeing now with also the growth of marijuana growing and legalization that we're seeing throughout our region, and hemp production from within that is also a part of that, at least in our state. So it's more accessible now than it was before, and I think that's another great thing to look at in terms of that supply chain and utilizing agricultural residues and byproducts from processes. I mean, for us, plants that grow medicine, plants that grow food, that's again, that like layering of the chain that we can do as builders. And I love that. So I wanted to also add, we have been working with and talking with some folks who have been really exploring the possibilities around mycofoam and mushroom kind of building elements. So not just as insulation, we're all aware of how, mycofoam is useful as an insulation, but we've been working with somebody who's piloting and working on actually structural columns made with mycofoam or with mushrooms. So that's a really neat thing too, because I think looking towards what are wood replacements for our structural elements when we're looking at really building on the scale, and we really have to be thoughtful and careful about our forests and forest management and how we're doing that. And we all know that wood is a very tricky thing when you start to look at that in terms of carbon storage. So I think also we need to start to push towards those next things of what are we going to frame with, what is framing going to look like in this new biophilic, house that we're all pushing towards. So.
Yeah, totally agree. It's not really low embodied carbon if it's just, lumber that's not managed well and forests that aren't managed well. Absolutely.
Kyle brought up
grow the house, like my daughter said.
Grow the house. Yeah.
Exactly. Kyle brought up a good comment in the chat that it's much easier to buy FSC certified framing lumber in scale for like panelization operations than it is for us to get it at the yard. In kind of a more concrete realm again, because I want to see more people do this. What are some things that architects and designers and builders should be aware of when considering the design of a building if we're looking at going towards panelization? Are there restrictions or things that start to push it outside of the realm of feasibility, or how can we optimize designs to deliver panelized or offsite construction better?
That's a great question. Yeah, absolutely. So if you're building walls and they're going to go down the road vertically, which they need to do if they have windows in them, then you're limited to 10 feet of building of wall height. And if you have taller walls, they have to ship sideways, which is, another process to turn them around. That's an important thing. I've looked at architects' plans and, sort of said, sorry, we can't do that because, another big issue is windows that are too big to feasibly put in a panel have to be installed on site. And so you're kind of defeating the panelization process. So people love the 8-foot by 16-foot lift and slide door, but that thing is a nightmare to install. You've got to transport it and then you've got to install it on site. And if you can it's what I'm really interested in is how the architecture is affected by panelization. On the other hand, on the other side is, the build smart concept of 1 foot, 2 foot, 4 foot, 5 foot, 8 foot, and the windows are all really standardized. And that, may not work for many architects. But as was mentioned earlier, sometimes architects like constraints, like here's your system, design a cool house with these 5 kinds of panels and these 5 different types of windows. So that's where, that's where it gets clever, where you've got to figure out how to do that.
I think for me, sorry.
Oh, I was going to say too, is like, we have all these custom designs, right? Everybody wants to customize it. But then if you have these shop drawings and you've created this thing, maybe the first one is custom. How do we get developers to buy into this, right? Because all they want to do is deal with the land. We've figured out how to do better panelization. Let's get them on board with then building multiples of it in.
Yeah.
Emily, it's funny that you say this because we literally just had a lead come through our office this week of a developer that wants to do 12 passive house level, semi-luxury projects, panelized, like out of the gate. Their comment was they want it panelized.
It's cost. I mean, developers, they only think about dollars, really. So if you can give them a house that's 10% cheaper, they are psyched.
Can I just go back to the architect, what's different? Because I was kind of on the side of, I was the architect on our first panelized building. And I think the big learning curve for me was that the construction administration actually shifts to the front. So you kind of have to rethink your contract structure a little bit, because if you're used to, just kind of setting up your contract through schematic design development, and then maybe have construction administration hourly, it's very different. You kind of lose as an architect because you kind of put all your construction administration hours up in, in your design development basically, or construction drawings. So that's just something that I learned, and we typically talk to the architects about that early on.
Dun, dun, dun.
I know.
Sorry, I'm just trying to catch up on all the questions that are popular in here.
There's a lot going on in the chat.
I gave up on the chat about a half an hour ago. So sorry, chat people.
I'm going to fill the dead space because I see a lot of FSC, and I do want to say that I think another benefit of the panel thing is that, like right now, lumber costs are just so completely insane, and none of us really know where they're going. And so we kind of feel like no matter what the budget is for the project, everyone is still facing ridiculous costs. And so it's like the best time ever to try to really, really focus in on efficiencies. And so that's, like I said, as soon as you panelize or fabricate something, you need to design it. And then when you need to design it, you get your eyes on it in a different way, and you analyze it much more closely, and you can quantify it, and you can spin it out to try different configurations. And I just think that panelization, can do that so that you're getting FSC lumber cheaper because you're buying volume. The panel company's going to get FSC lumber. They're also, once they're committed to it, they're not going to move it out of their project. It becomes their standard. They can get great relationships with the lumber suppliers. And then you add that in the whole design efficiencies that we can really vet out. And especially when they're doing some of the model homes that they're doing, I just think that is a really important piece right now. That's a benefit I think that the panelization brings.
Are people using their local lumber mills, or where are people sourcing their lumber from? Framing lumber.
The west coast of Canada.
Not for long. Not much left.
Well, I don't know. I mean, have folks?
I can't afford to buy any lumber, so I'm.
Right.
I'm just,
what lumber? Yeah.
Yeah, I'm not.
Well,
I'm buying gold bars instead.
That's exactly why I'm talking about it, because our local mills here in Vermont are way cheaper than if you were to go to Lowe's and try to buy, or wherever, and try to buy a stick. So because the Pacific Northwest stuff, as you're saying, is so extremely expensive right now, local Vermont produced lumber, framing lumber is huge. And it's one of the reasons that our prices aren't going through the roof in comparison to
That's
other
awesome.
people. So I really recommend, I don't know, everybody's in different states and whatever, but check it out, look around, because there are multi-generational mills that, people have been stewarding the land for a long time, and it's an option.
So I have a question about that, Ace.
Not graded.
Yeah, well, that's what I was just going to say. We
That's
got
the
into
hoop.
this when Jacob was on. We spent a lot on the whole chat. We spent a lot of time talking about this,
Okay.
and the question really is, and it's not like I don't believe in absolutely every certification effort, because I know that there's a lot of sort of overdone red tape. But I will say that it feels like in the market, given the chance to basically put a green label on something with as little effort and visibility as possible, does seem to happen in our industry. And so my question is, if it's local, right, but it is not really, I mean, everyone says that they're stewarding the land. If there's not really a third party review in some kind of chain of custody, then how do we know, right? And Jacob actually asked me that question, because we were talking about wood, and he's like, I'm looking at embodied carbon of all these materials. I'm going to ask you the question, how do you really know? And so it's complicated at these, from cradle to grave, wood is complicated, but how do you actually know if now you're buying it from a local lumber source, right? How do you know?
Well, we don't know down to the bullet point, but what I can tell you is, we have gone physically with our sawyers into their wood lots that they manage. Yeah. And I've watched them harvest trees, for us. So, That's I don't awesome. Know. Yeah. So I'm you can go, you can ask to go see it. There's no reason not to. And you're right. We're not
scale though. At scale. Can you do that at scale? Right.
Well, what is scale? I think I would ask that question. I'm thinking about what you said, Alan. It's we're not going to do, what do we mean when we say scale? And I think let's really query that, because a distributed network where we're actually utilizing place-based and whatever. Right. I'm not saying we can't go beyond that, right? But at least to rethink how we think about our supply chains, I think is a key point in this. So That's what I would say to you is I totally agree. No, family sawmill is not going to provide for, every project, but it is going to provide for the projects that are near to it. So, and certainly the more and better we can do. I think the quest for perfection and absolute clarity is a mistake. I think we can get as close as we can with as much as we know at this point. And that's actually really important that we do that and keep querying and keep questioning and keep getting better and better at understanding where that carbon is, understanding, those embodied costs, looking at the full picture and the full cycle. I just think if we value in things besides just carbon, because that's the other thing, you have to look at it. Yes, carbon is critical. We have to do that, right? But then we have to look at all the other ways in which we're supporting a system that's going to mean we're around past 10 years, right? And there's more to that than just, is it this amount of carbon or that amount, is it exactly stewarded in the right way? I think, yeah.
Don't let perfect be the enemy of the good.
Exactly.
Yeah, well said.
Pretty good is still pretty good.
Yeah.
Right. And maybe small scale, maybe you're totally right, probably totally right, that a small scale forestry operation is just by nature, is going to be way better than a corporate owned, right?
Because they can't fuck it up in the same way, because they know they're right there. What I mean? And to a certain extent,
just don't fuck it up is the certification.
They can't afford to.
This is not fucked up.
But that's the point, Ben. Exactly. Is when we think about indigenous practices, which again, I want to, we look at the list from, Carbon Drawdown Project, right? It's supporting indigenous land stewardship is one of the biggest impact things we can do to reverse climate change. And why is that? Because indigenous communities and cultures historically are deeply connected to the land that they're rooted in.
Right.
And guess what? That's also true for every person who identifies as white in this country who got consolidated into whiteness. We all came from indigenous cultures as well. That everybody comes from a place where you're connected. And so that to me is the piece where we have to relearn that connection, where you're not gonna, shit where you drink or whatever, right? Because when you know that this is what you're depending on, I'm not saying it's perfect, but it's at least that beginning part of I'm in relationship with this place. And that's at least a starting point to how we're going to, be in a really different state of affairs with thinking about a resource, right? Like, no, we're a part of a living organism called Earth. And like, as humans, that's what we're a part of. And so we have to, with everything that we're doing, act in that relationship with the place.
Yeah, I totally agree with that. And I also can also see what Steve was saying about scale. Like the scale of the problem is so enormous. And I don't know, it's trying to marry those two is the big challenge, right?
Yeah.
Because we've got to make a lot of change fast. And that has to mean some larger scale than, I'm all for local, distributed networks. I just wonder how they can actually produce enough.
So we're not going to build our way out of this, though. There's always that thing that we keep coming back to. So it's like we keep talking about scale because we all have to deal with scale on a day-to-day in what we're doing. But it's kind of a red herring because scaling this has some long-term benefit, but it's not going to short-term solve it. And I guess to Ace's point, I'd much rather give a $30,000 lumber order and pay $5,000 for a USDA Forester grader to come out and keep that money down the road for me than to give it to Canfor, who's raking in billions and billions of dollars this year.
Yeah. Oh yeah.
Because realistically, it's going to take a little more legwork on our end to do it, but the benefit's there,
Yeah.
if you have that opportunity local to you. Not everybody does.
Right.
So our partner in Montana, they're kind of they're raising us on the CLT thing. They've been doing it for a while. They have their Stoltz timber systems, and they partnered with FH Stoltz, that is a 100-year-old or something local Montana forester, and so they have that, like, that's the perfect model, right? They're getting the lumber literally from their partner that is the steward of the land. And it's a family owned, and they understand what it means to like balance, revenue with responsibility. And they're finding ways to use small diameter timber to create CLT and other panel, basically, and they're adding value to what otherwise is just a commodity, 2x stick. So it's everything you're saying, but that's one potential vendor. Like, how do you get that slide that Alan had where you have 500 builders producing a certain, that kind of networking? How do you connect that then to what Ace is saying, which is like, you need like a network of a bunch of these local responsible, like that sounds amazing, but how do you do that?
Well,
I think we just do it is the answer, because we could all do that. Like, that's the coolest part. We don't have to wait for somebody. It's something we can do right now.
But Adam Cohen, I've been talking to him about this idea and putting together a network of small scale panelized builders to do his modular panel idea, but with all, carbon sequestering materials. And I think New Frameworks has been talking to them as well. So,
That's cool. That's great to hear. I'm very excited about that.
Yeah.
That's what we do the BS and Beer show for, is to get everybody together.
Form a
All
super
agree to
group.
work together and then make a super group and take over the world. But it's 7:30, so
We're too tired to do that right now.
I get to be the bearer of bad news. Everybody
Wah,
talked to
wah.
one person. Everybody talked to one person in their network tonight. There were 150 people on tonight. If everybody was on tonight, talk to one person. We're, 2 people,
That's a good way to
3
look
people,
at it, Emily.
2 people, 3 people in their network, then, we're moving towards that. So I just wanted to say thank you. I'm sorry to be the bearer of bad news, because I think this discussion could go on for a couple more hours.
Right.
That was so fun. Thank you, everyone.
Thank you. Yeah, thanks so much for having
Thank
me.
you.
Yeah.
This is great.
Thank you all for taking
Likewise.
your valuable time and joining us tonight.
Yes,
Really
much
a pleasure.
appreciated
Yeah.
on everybody's part. Okay.
Good night,
Good night,
all.
all.
Together.
Good night.
Bye-bye.